Hi, hello folks, we are taking up the chapter 2 now. Chapter 2 is relations and functions, and we are taking up the exercise 2.1. The exercise 2.1, we are dealing with the concept called as Cartesian product. So that is how we will be moving across. Nothing new to us. Cartesian product means earlier in the set theory we had learnt one set. Now we are taking two sets at a time, and the elements of this set Cartesian product is always represented as an ordered pair. Ordered pair is nothing new to us. We have learnt it in our coordinate geometry in the 9th standard. So that is what is called as an ordered pair. This is a brief insight of what Cartesian product is. Let's go to the exercise directly and take up questions from there. We are starting with the exercise 2.1, and we are taking up the question number 1 there. Let's see what it says. Question number 1 says, if x plus 3 plus 1 and y minus 2 by 3 in ordered pair is equal to 5 by 3 equal to 1 by 3, then you have to find the value of x and y. Quite reasonable. They say that there is terms like this, x by 3 plus 1, and the next term is y minus 2 by 3, which is equal to 5 by 3 and 1 by 3. If that is the case, then you have to find out what is the value of x and y. We just have to correspond the elements. When two ordered pairs are equal, it automatically means that this is equal to this and this is equal to this. That is the meaning. First element equal to first element, second element equal to second element. And let's find out how it goes. So what happens? Here we will have x by 3 plus 1 becoming equal to 5 by 3 and y minus 2 by 3 becoming equal to 1 by 3. Let's solve it. So that's what will give us the values of x and y. Now when we solve this, the plus 1 will go on the other side. So it will become 5 by 3 minus 1, and then automatically when we equalize it, it will become into 3 into 3. So probably it will become 5 minus 3 by 3 x by 3, and x by 3 therefore will become 2 by 3. We can have the 2 cancelled off, so x value becomes 2. Similarly, we can talk about the y value also. The minus 2 by 3, it could go on the other side, so it will become plus 2 by 3, and then denominators are same, so you can add the numerators. So like that you will get 1 plus 2 by 3, and you get the answer as 3 by 3, which is 1. So the y value comes to 1, and this is the question. Find out what is x and y value. X is 2 and y is 1. That's about the question number 1. Now we are moving to the question number 2, and question number 2 says that if set A has 3 elements and set B, they have given us element 3, 4 and 5, find the number of elements in A cross B. Again, quite simple. They say that set A has got 3 elements, and then set B has got the elements 3, 4, 5. That means how many elements it has got? It has got 3 elements. So if that is the case, find the number of elements in A cross B. Always the number of elements in the Cartesian product is a number of elements, it's a product of the number of elements of both the sets. So that's quite easy. Now if you want, you can specify here the number of elements in A is 3 and number of elements in B is also 3. So therefore the number of elements in A cross B Cartesian product is n of A into n of B, and that will come to 3 into 3, 9. So the number of elements in the Cartesian product comes up to 9. Then we come to the third question. It says that if G has got elements 7, 8, if G has got the elements, it's a set which has got element 7, 8, and if H has got element 5, 4 and 2. If that is the case, they ask us, find out G cross H and H cross G. It's a beautiful question. Why? Because it gives us, it fixes our base about the Cartesian product. We got to know what is a Cartesian product. Only when we list the Cartesian product, the idea of Cartesian product is clear in our mind. So it's a beautiful question in that way. So let's list. We will list the elements of G cross H, and we will also list the elements of H cross G. So let's see. First let's list therefore H cross G. Now, when it is H cross G, first element from H, second element from G, that's all. So we take the first element from H, that's 5 for instance, and the second element from G, that's 7, 5, 8. Then you could have 4, 7, 4, 8. You could have 2, 7, 2, 8. That's about H cross G, quite simple. Then we go to G cross H, first element from G, second element from H. So let's have G cross H. Therefore, G cross H, first element from G, that means 7, and second element from H. So you could have 7, 5, you could have 7, 4, you could have 7, 2. Then you could also have 8, 5, you could have 8, 4, this is 8, 2. So that's about the listing. It makes the idea of Cartesian product very clear in our mind when we do this kind of listing. So that is about, this was our part 1 video of this exercise 2.1. The remaining question we will take up in the other parts. Thank you.